focus on evolution of rail transport. And here, the hydrogen train and Hyperloops. We are adding almost one Swiss rail to our system every year. And here the statistics speaks for itself that the track that is 128,000 kilometers odd and such vital figures, this speaks volumes about the extent of opportunities available with the Indian Railways. Now, in comparison to the global standards, Indian Railways, passenger kilometer wise, it is ranking number 1 in the world. It is ranking number 2 in the world vis-a-vis number of workforce, ranked number 3 in the world vis-a-vis number of locomotives it possesses, and rank 4 for the freight 10 kilometers which it carries and length of network all over the world. It is ranked 4th in the world. So it is really a gigantic system. Now, for Indian Railways, technological vision is that network expansion. This is our, recently we have done a Chintan over how to add 10,000 kilometers of track every year. So this is one, similarly 5 ton of loading every day. Similarly, several other Chintans have been done and we are adding our capacity augmentation accordingly. High-speed train introduction is going to be one of the vision. Reducing carbon footprints in which we have covered during the panel discussion. That is our vision. Yes, train safety has to be one of our strong foot, and track modernization as it's happening around the world remains one of our technological vision future. Now, coming to the topic that is of hydrogen usage, that is the environmental policy which is having zero carbon footprint by 2070, zero net carbon footprint. Then we need to have that renewable and clean energy source, and also to mitigate the carbon dioxide emission which is happening. Indian carbon dioxide emissions are on higher strides. That is 2.5 gigaton in 2018, which comprises 7.3 of the entire CO2 emission in the world. We need to have improved air quality and reduced fossil fuel imports. India imports around 83% of our crude oil and 50% of the natural gas, which puts great burdens on the exchequer that needs to be reduced. So with this background, the hydrogen train, how does it works? That is being tried to be explained. And here the hydrogen is stored in 4 fuel tanks. The fuel cell that converts hydrogen and oxygen into water and electricity. It is as simple. H2O2 makes it water, and then electricity is produced in the process. And energy is then stored into lithium batteries, and electric motors then move with this energy. The advantage of hydrogen fuel cells is that it is renewable, and hydrogen is available in plenty all around us. This is very clean and flexible energy source to support zero carbon energy. And this is one of the most powerful energy efficient than fossil fuel. And the charging time is very fast. That is about 5% that it gets charged within 5 minutes, in comparison to 30 minutes for the traditional charging. And of course, the emission is almost zero. There's no noise pollution. There's long usage time that it runs for longer time. And it leads to democratization of power supply in that sense that if some country don't possess fossil fuel, oil or natural gas, even it can utilize this technology to take their fair share in the energy market. So, the disadvantage of hydrogen fuel cell is that hydrogen extraction itself, making of the hydrogen itself is very tedious and at present costly process. hydrogen is inflammable. But the good point is that since it is light, it goes up, so that the intensity is reduced. The storage and infrastructure of the hydrogen is a problem, and then cost of raw materials, that is lithium, selenium, which is used in this in the fuel cell, is very, very costly, and a lot of investment is required in this process to make hydrogens a reality, and reality to enter in a big way. Now I'll deal what type of hydrogens which are available. So firstly, the gray hydrogen, that is made from the natural gas through steam methane reforming process. Brown hydrogen is from the stratified gasification of the coal. This gray hydrogen has been dominant form of hydrogen so far, but now we have made a transition from gray to blue, and here there's another process that carbon capture and storage is done. So this is better than the gray, but the next better form is green hydrogen, which is our target as of now, and that is produced through renewable energy source. This is, it's clean, but currently expensive. Turquoise hydrogen is manufactured by decomposition of methane to carbon and hydrogen. Here again, there is no CO2 emission. And the hydrogen produced through the nuclear power, that is called yellow hydrogen. And here again, centralized hydrogen production units can be set up. So the use of hydrogen at present is in ammonia and methanol production, as well as in steel production as of now, where gray hydrogen is being used. And future in the transportation, thermal power, building heat, and fuel cells, there lies the future for the hydrogens. Hydrogen in mobility sector has been is being introduced, and it is there with the hydrogen blending CNG, hydrogen in IC engine. But fuel cell, that is the efficient technology that is being used for where the hydrogen is being used, and that needs to be popularized. Now, in the fuel cell project, which is taken up by Indian Railways, here we have onboard diesel power car we have taken and removed the engine, traction and alternator, and then retrofitment of the fuel cell is done, and retrofitment of associated electronics is done. The ground facility is being developed at Jind, that is for running the train between Sonpat Jind, and hydrogen production, storage and dispensing is being done there. On the ground for Jind hydrogen project, alkaline electrolyzer is there, which fills up the hydrogen in low pressure buffer vessel of type 1 cylinders, which is compressed by compressor through into the high pressure vessel, and then it is dispensed off. Again, the type of hydrogen cylinders have evolved, and presently we are using the type 4 fully wrapped with the FRP type of hydrogen cylinder, which can take up to 1000 bars of pressure. This type 4 cylinder is having the carbon fiber wrapping and CRPF layer, having a strength to bear the pressure of the hydrogen. Now, there is very minimal requirement at the ground facility, which we have seen at Jind for production of the hydrogen. And this is the tentative layout of equipment in hydrogen fuel cell. Hydrogen fuel cell, which takes the hydrogen from the hydrogen tank, and through the AC-DC converter, it is converted into electricity in the battery, and auxiliary power unit is charged through it, and then variable voltage, variable frequency driver inverter, which drives the engine. So the scope of the project is the equipments are removed from the electrical multiple unit, and then building blocks with 1600 horsepower hydrogen fuel is retrofitted. Now, these are the fuel cell related projects on Indian Railways. That is fuel cell on 1 DMU rake, as I have told, Jind Sonpat section. 2 narrow gauge locomotives are being on Kalka Shimla is being fitted with the hydrogen fuel cell. Fuel cell hybrid locomotives are being built at DMW Patiala, and where the underframe of new WDM-3D will be used as a platform for fuel cell hybrid locomotive. And for some of the heritage routes, we have, because there the electrification is not there, there this hydrogen train is proposed to be run, and that feasibility survey is being done. This is the heritage route. Indian Railway briefs are there, and these are the proposed routes where the hydrogen trains are proposed to be taken on the heritage routes. Now, cost comparison, hydrogen train at present is quite costly when we include the cost infrastructure and in comparison to electric and diesel, and that needs to be brought down by the research and by popularizing and making greater investment in its manufacturing. So currently, hydro-rail vehicles are hybrid, wherein for industrial and passenger rail, freight rail, mine railways, light and rapid rail, this is being used. China has recently introduced hydrogen powertrain, where they have a range of 600 kilometers with a single tank, and maximum speed 160 kmph has been achieved, where in Germany, they have run for 1,000 kilometers with the maximum speed of 140 kmph. So that was about hydrogen train. Now we have got some time to, we will be discussing the prospects for Hyperloop. That is also a great innovation that is going to be there after Elon Musk unmasked is a strategy for bringing Hyperloop, which is going to be a game changer in the transportation technology. So here, the working principle is that there is an electric compressor fan at the nose of the pod, which maintains the pressure, and it created a low, which helps in creation of a low suspension system with the air bearing at the bottom. Now there is a rotor and there is a stator. That external linear electric motor is used to power the fans. And the capacity of each capsule will be around 25 to 50 passengers, and or carrying 15 to 18,000 kg of cargo. And the working principle is that in the tube, which is evacuated, it's not fully vacuum, it is partially evacuated cylindrical tube, like the track do in the conventional system. And the tube can be possibly built of steel and supported on concrete pylons. The stator for acceleration and deceleration of capsule is there, and there are mounted solar panels on the tube to make it fully self-powering. So here the air is pushed backward as well as downward to create low pressure in the tube, and major downward direction form of air that provides the cushion wherein it floats the tube in the tube. And thus high speed is maintained without much external acceleration. So it is conceptualized to have the speed of around 100 kilometers per hour. The economics is that its construction and maintenance cost is considerably less than high-speed train network, and it has got very low operation cost. The convenience is that it is gradual acceleration and deceleration is there, and sustainability, there is no carbon emission, no noise pollution, and can be built underground or crossing railway body. And then safety, weather and disaster resistance is there, and possible self-powering capacity is there. India has certain projects in 2016 between Chennai, Bangalore, and in 2018 between Pune and Mumbai, some loop projects were conceptualized. Recently, Virgin Hyperloop has announced that instead of working for the passengers, they'll focus towards cargo. And very recently, Indian Railways has invited request for proposal for consultant for the development of indigenous Hyperloop system, maglev or linear induction motor. So Indian Railways is also coming up with its own vision. And this is the international journey where Virgin Hyperloop in 2017 was formed with the Virgin Hyperloop 1, Hyperloop Transportation Technology, Hyperloop and Transport Canadian company. So all these have joined together and also working at international level. Realistically, 2027 to 28 seems to be the earlier time where Hyperloop can be a concept which can be delivered. It off with saying that the best way to predict the future is to create it. So let's create a new future. Thank you very much.